For this lesson, we're going to move from simplifying rational expressions to solving rational equations. So our objective is that we can solve rational equations. So I'm going to start by reviewing over just solving a quadratic. So on an equation like this, remember you want to get 0 on one side. So we're going to add 7x to both sides. So remember what you do to one side of the equation, you got to do to the other. And then we're going to factor out the x and then set each factor equal to 0. X equals 0, x plus 7 equals 0, and so x equals -7. So our two answers are 0 and -7 for a solution. Now, when we get that, we got to remember that in rational equations, we're going to be dealing with fractions, with polynomials in them. So we're going to look at these types of equations, and when you look at these, you might ask the question to yourself, which of these would be easier to solve? Well, in some respects, these are all the same equation. They all have the same solution. In fact, if we start with this equation, this would be a step in the process, and then this would be another step in the process. So what I'm going to show you is how to get from here to here, possibly with a couple different ways to solve the equation. So when we look at this, I want to give you some background on this. When you want to solve a rational equation, remember, because we have denominators, you have to make sure that you check the denominator restrictions, okay? So the denominator restrictions may eliminate answers. So you've got to make sure you do this check, because in the process of multiplying and getting rid of the fractions and the denominators, you might create a solution that has one of these restrictions. So if you look at this, the original equation here, we know that the restriction on this first one is that x cannot equal 1. So if we were to solve this equation and solve it and get that x equals 1, we'd have to eliminate it. It wouldn't be an answer in the final answers. So let's try doing this one. We're actually going to do this problem down here as an example. We're going to first of all look at a first method where we're going to get fractions with the same denominator. This is where if you have an equation with fractions with the same denominator, you're going to set the numerators equal. That's the process for doing it this way. So what happens is if you have the same denominator on both sides, then the numerators have to be equal because the fractions are equal. Here's an example. These denominators are not equal, so let's get a common denominator. Our least common denominator here is going to be, we'll take the 5 and we'll take the x minus 1. Now when we do that, this first fraction, to get that common denominator, I'm going to multiply it by x minus 1 over x minus 1. And on this side, I'm going to go ahead and do the same thing. Multiply by 5 over 5 to get the common denominator, 5 times x minus 1. So when I do this, I'm going to have on the top here, when I multiply these two together, I'm going to get x squared minus 1x plus 3x minus 3 all over my common denominator, 5 times x minus 1 equals 5 over 5 times x minus 1. Now if you look at this equation, when I simplify this here, I'm going to get that middle equation up here. If you look here, I had this times this over that common denominator equals 5 over that common denominator. So this is where we started. This became a next step. Once you have that, you can set those numerators equal to each other. So this numerator, which is x squared minus x plus 3x is plus 2x, minus 3 is going to equal 5. I can get rid of the denominators because two equal fractions, same denominator, the numerators have to equal each other. Now I'm going to just solve this equation. I'm going to subtract 5 from both sides. Get minus 8. Now I'm gonna factor this once it's equal to 0. I get x, and for this one I'm gonna get x plus 4, x minus 2 when I factor it. Remember, when we have two things that multiply to equal 0, set each of them equal to 0. So x plus 4 equals 0, x is going to equal negative 4, and then x minus 2 equals 0, x equals 2. Now we have to check our restrictions. Back at the original problem, the restriction, remember, as we stated before, was that x cannot equal 1, because if it did, that denominator would equal 1. Neither one of these two is that restriction, so the answer is just negative 4, 2. So the first method is to take the equation with denominators, get the denominators the same, and set the numerators equal, solve, and then check your answers. All right, let's do it a second way. The second way is to eliminate the denominators, and this will probably be the preferred method for most of you. What it does is it jumps down to this stage here, not having any denominators quicker in most problems. So the key idea here is that you want to multiply both sides of the equation by the LCD to eliminate denominators. That is the key idea for this one. All right, so for when we're doing this, let's look back at this equation. We're going to go ahead and solve it using this method. It's going to look similar in many of the steps. I'm going to take this equation, x plus 3 over 5 equal to 1 over x minus 1. Now this second method, the advantage it has, because it's an equation, when we were doing simplifying rational expressions, you had to multiply numerator and denominator by the same thing. But because it's an equation, we can multiply both sides by the same thing. We can go ahead and take our LCD, which is equal to 5 times x minus 1. And if I take and multiply both sides by that least common denominator, so 5 times x minus 1, I'll put it over 1 just to represent the fraction. Once you do it on one side of the equation, you got to do it on the other. 5 times x minus 1. When I multiply it by this fraction, notice that the 5's reduce. And so what I'm left with is x minus 1 times x plus 3. And over here, notice that the x minus 1's cancel. And I'm left with just a 5. This looks a lot like, in this method up here, looks a lot like this technique here, because if I multiply these two out, I get the x squared plus 2x minus 3. So this technique is the same as the other one. We just get to this step faster by multiplying by the least common denominator on both sides. So when I multiply this out, I'll get x squared plus 2x minus 3 equals 5. Go ahead and subtract 5 from both sides. And then factor x plus 4, x minus 2 equals 0. And then when I solve these two, this is going to give me the x equals negative 4. This is going to give me the x equals 2, which is the same as what we did up here. The work looks very similar. It's just that we get to this step quicker by multiplying by the least common denominator on both sides to eliminate the denominators. So this will probably be the technique that most of you will use to solve your equation. So let's go ahead and use this technique to try this problem here. It's a little more complicated. The first thing I would do is go ahead and factor this denominator to get the LCD. And this factors into x plus 5, x plus 3. So notice that's the exact same denominator as that one, as these other two combined. Now I'm not going to factor this numerator, just leave it alone. You're only factoring the denominators. Okay, now I'm going to find my LCD. I'll put that over here. My LCD is equal to x plus 5 times x plus 3. I take each of those factors. I don't have to take it a second time. Let's list our restrictions here because we have to always check our restrictions. X cannot equal -5 because of this denominator and that one, and x cannot equal -3 because of this denominator and that one. So let's go ahead and multiply both sides. We're going to multiply this side by the LCD, which is going to be x plus 5 times x plus 3. So multiply this side by it. We multiply it over here also, x plus 5, x plus 3. Now on this side, notice that the x plus 3's cancel, and so you're left with 3 times x plus 5. Over here, I've got to distribute this through. Distribute it to here, and the x plus 5's cancel. So I'm left with 2x times the x plus 3 because the x plus 5's cancel. Here I'm going to multiply it by this fraction, and the entire denominator cancels with that LCD, so I'm left with is x squared minus x minus 10. I'm going to put it in parentheses because I have to distribute through that negative. So simplifying now and solving, 2x squared plus 6x minus x squared, distribute it through, you get a plus x. Distribute that through, you get a plus 10, equals 3x plus 15. Now we've got a quadratic to solve. Let's go ahead and simplify this side. 2x squared minus x squared is just 1x squared. 6x plus x is plus 7x. And then we've got the plus 10. Now let's go ahead and solve by getting it equal to 0. So subtract 3x from both sides. X squared plus 4x. And then subtract the 15, you get minus 5. It's going to equal 0 by subtracting those two. Now when we factor this, this is going to be x plus 5, x minus 1 when I factor it. This, when I solve it, set it equal to 0. And I get x equal to -5. Well, notice over here, we're not allowed to have -5 because that would give me a 0 in the original denominator. So because of the restrictions, I don't allow this answer. You've got to take it off. But this one, x minus 1 equals 0. You get x equal to 1, and notice that's not one of my restrictions. So there are two methods for solving rational equations. The first method is get the two fractions with the same denominator, set the numerators equal. The second method, which is probably the preferred one, is multiply both sides of the equation by that least common denominator. That will eliminate the denominators quicker. Then you solve the problem, making sure to check your restrictions at the end of the problem to see if one of your restrictions eliminates one of your answers.